Kajati ndi mu Zoom tokubira paka saa mukaaga. Ngenda kujjaawo. A very good morning to you all.
Good morning, teacher.
We are still continuing with our probability density functions. And today we'd like to introduce basically the sketching aspect, how we can go ahead and sketch the functions. Sometimes they might set a question when it is in terms of a sketch of a curve, and they can ask you to extract out the PDF, and then you design the f of x. So in that situation, we can also be in position to extract whatever we have and have the PDF illustrated in terms of f of x and its boundaries. So on that note, today's topic is basically sketching. Sketching the probability density functions. So we are going to sketch the PDFs. So in case you have, for example, a random variable, x has a PDF given by f of x is equal to a quarter x 0 less x less or equal to 2. Then we have a quarter into 4 minus x. And this boundary is 2 less or equal to x less or equal to 4, and then 0 elsewhere. And the question says sketch the function f of x. Now, first and foremost, it requires you to know what function these functions are, whether the function is linear, whether the function is quadratic, whether the function is cubed. You know, you should be, when we come to Backhouse 2, we shall learn of what we call exponential functions, e of x. We shall also have functions, other, like I said, some curves or some FPDFs. You can't access them now because you've not yet covered integration of trig functions. You've not yet covered exponential functions. But when you land on such functions, they are easy to bring on board because by that time, if you have already covered integration of trig functions, then here you know what to do. So you just apply the trig functions integrations, and then you can go ahead and handle whatever the question wants to handle. So the question says, sketch the curve. So to sketch this curve, one, look at the regions between 0 and 2. This region has 1, values of x. Then it also has values of f of x we can predict. Remember, on the curve, f of x represents y. So the first one can be 0. Our second one can be 2. So the function f of x is a quarter in that region. When I substitute 0, I still get what? 0. When I substitute 2, I'm going to get what? 2 times a quarter, the answer is a half. So I'm getting coordinates which are supposed to be represented in this form, x and f of x. Like I've said, f of x represents y. So for that reason, according to this, we shall have coordinates which are, you close this one off. Coordinates are going to be 0, 0. The second coordinate is going to be 0 up to, the second coordinate is going to be 2 up to something. 2 up to a half. Someone has forgotten to unmute. Please, someone mute. Who is that? Techno Canon. And remember to sign in with your names, please. I won't answer questions for people who are having no names. So that is the first region. The second region is the region where we have 2 less than x less than or equal to 4. In this region, I can predict the coordinates by saying I have x and f of x. And these coordinates expect x is 2 and x is 4. When I put x is 2 in the second one, I'll have 4 minus 2, which is a 2, times a quarter, which is also a half. When I put x is 4, I'll get 0. 0 times a quarter, I get 0. So I'll get coordinates which are 2, a half, and 4, 0. Now, why is this point the same as this point? Those 2 points are the same because 2 is the boundary of both regions. 2 is in this region and 2 is in that region. So the function f of x of 2 is supposed to be the same in region 1 and also in region 2. So that is why we have the same what? Same point. Now, when you look at this carefully, we can sketch the function. Because we don't have negatives, no need of considering negative values. So the y-axis is always represented by f of x. Then the x-axis is represented by the x bar coordinates. Now, we have the boundary function, which is, boundary coordinates, which is 2 in the x-axis. Then there is a 4. Then the highest value in the y-axis you have seen is positive a half. So it means we shall have to consider this point. Because these are linear functions, singular x represents a linear function. So they are lines. So you get a ruler and sketch from 0 up to this point where I have a half. Then from a half, the other one goes up to 4, 0. So you come back down. So it comes back to the x-axis and stops at 4. Meanwhile, this is a positive gradient because the x was positive. And meanwhile, this one is going to be a negative gradient. Why is this a negative gradient? Look at the x you have in the second region. The x you have is a negative, so it represents a negative slope, which goes downwards. Okay. After this topic, I will expect everyone to have a logbook because I'm going to introduce normal distribution, one of the last topics of probability. So as we prepare, people should get 1, a logbook, 2, a standard original calculator, because there are 2 methods. We use a calc or we use a log table. So I'll need those 2 items. So let me start announcing, even if we have around 3 or 2 more lessons to reach there. But let me announce when it is still early so that people always get ready. Okay, so that's how the function had to go when sketching it. Let me get another one. Unless if someone has a question. A continuous random variable, continuous random variable x has a probability density function given by f of x is equal to 3 out of 32 of x squared from 0 less x less 2, 3 out of 32 of 6 minus x over 2 less x less what? 6, and then 0 otherwise. Sketch the function and deduce the mode. Sketch the function and deduce the mode. Now, in this case, f of x, remember, is probability in actual sense. So whenever I bring about a concept of the mode, you need to look for the highest value of the probability. Now, for example, if you look at this previous number, the highest value of f of x, these are probabilities. If they had asked the mode in the first question, the highest value of f of x is 1/2. It occurs at what x value? At 2. In question 1, the mode would have been what? The mode would have been 2. Now, we are going to sketch the curve of this second number. And when we realize that point where we have the highest probability, then the corresponding value of x will be predicting the what? The mode. So to start with, the region 0 less x less 2. When you put there x is 0, you get f of x is also 0. When you put there x is 2, unless if you want me to draw the table, okay. If you want me to still draw the table, we are saying x, f of x, we are saying 0, 0. The other one is 2. When you put 2 there, you get 4. 4 divided by 32, you get 8. And this is 3 out of 8. Let me put a barrier here, so that I can consider all of them at once. 2 less x less 6. When the value of x is 2, we shall get what? 6 minus 2 is 4, which is the same answer, which is 3 out of what? 8, because it's the boundary. Then we have of the two regions. When you put 6, you still get 0. When I put 6, I'll get 0. But this second one is a line, while the first one is a curve. Which curve passes through the x-axis? Because when x is 0, y is also 0. So if I sketch the function, it would look like this. This would be my x, this would be my f of x, which is the y-axis, though it's a probability. We have here 0, we have x is 2, we have x is 6. But we have the highest probability as 3 out of 8. Between the 0 and 2, the curve is the graph is a curve. We intersect here. Between 2 and 6, the curve is a line, but a line with a negative gradient. So I can sketch my line here like this. Then, because between 0 and 2 is a curve, the curve can be in this shape. Okay, so therefore, at this point, where we have the greatest probability, which is 3 out of 8, gives us the mode. Therefore, the mode is also what? The mode is also 2. But that doesn't mean that all the time the mode is 2. No. Don't cry. Some of you might start crying, hey, the mode is always 2. Along the x-axis, look for where 2 is. That's where the mode is. No. You predict the mode from the highest possible outcome, which is the highest probability. All right? Okay. Unless if someone has a question.
Excuse.
Yes, please.
So is it the x squared which has made you to say it's a curve? Because
Yeah.
I've not got that way.
Yes, this is a curve. Well, this one is a what? A line. Idea is in this shape. Then the other one is a straight line. Okay? So it's supposed to be a straight line and a curve. Now, sometimes some of us who are not very comfortable with seeing that it is a curve. You know, curves start from x squared, x cubed, x power, for all those until you go to wherever you can stop. They are all curves. It's only x that is a line. All these ones, which are quadratic, are what? Quadratic and above are curves. So if in case you do not know how to sketch the curve, then you would have investigated some values between 0 and 1, like values like x is 1, x is 1.5. But since you're being taught by 5-star teachers and you're in 5-star schools, most of you, by now you should be knowing what x squared stands for and how the curve looks like. That is if you're solving enough numbers. If you're solving less numbers, you'll never know. You'll just wonder, how has the teacher sketched? How have my friends sketched? But if you practice, you'll definitely get there.
Sir.
Yes, please.
Why is 2 the mode?
Why is 2 the mode? Because it's the greatest probability we have according to this curve. It is the highest value of f of x. Okay. The highest value of f of x you have is the mode in both regions you have. Because if you had investigated x is 1 would have been here. The probability of it would be somewhere around here. When you put there 1, you get 3 over 2, not 3 over 32. If you put here 5 is also somewhere around this one. Perhaps when you put there 5, you do get 6 minus 5, which is 3 over 32, which is the same. Yeah? When you put there 3 could be somewhere around here. All those values are below 3 over 8. So 3 over 8 is the highest f of x, or the highest probability. And thus, if it's the highest probability, its corresponding x value is the mode. So you look for the value which has the greatest what? Probability. So you note it somewhere that the mode is got from the highest f of x, or probability. Someone's coming in late. Who is that one? Okay. Now there's another, you know, we have been seeing numbers before which had k, lambda, unknowns. Then they tell you to find the unknown first when we integrated and equated to 1. Now this time round, they can set a number, and this is another easier way of getting the unknown by sketching the graph and finding the area under the graph. Example 3. A continuous random variable x has a PDF given by f of x is equal to kx from 0 less x less 2. It also has 4k into 1 minus x out of 4. Between 2 less x less 4. It has 0 otherwise. Sketch the graph of f of x, and hence determine the value of k and the mode. Hence determine the value of k and the mode. Very good. Now they will set a number in this form. But you should know, because the x does not have any square or cube or what, it means all those regions are represented by lines. The first one is a line with positive x, which is a positive slope. The second one has a negative x, which has a negative gradient. So you should recall when we have a positive gradient, when we have a negative gradient. So when you're sketching, you mind about that. Now, in this case, still use the same techniques to investigate the points. So that we can have x, f of x, where we have 0, here we shall have 2. My boundary, I go to the region of 2 less x less 4. Then I investigate when we have 2 and when we have what? 4. When x is 0, we still get what? In the first region. When I put x is 2, I'll get 2k. Do you see that? Then the second one, when you put here 2, you'll get a half. 1 minus a half is a half. A half times 4, you'll get 2k. So this is 2k. Then lastly, when x is 4, I'll get 1 minus 1, and the answer is 0. So the coordinates I have are 0, 0 on this side, and then I have 2 and 2k in that region. Then this side I have 2 and 2k still, and also we have 4 and 0. I hope we now all know why we have 2k on both sides, because it is the what? The boundary of those two regions. Therefore, when I sketch, because both of them are positives, I will have here x, I will have here f of x. When x is 0, when x is 2, when x is 4, we have f of x is 0, we have f of x is 2, which 2 has a k. So f of x is 2k. When does that occur? It occurs when x is actually 2. But that between 0 and 2, the curve is a straight line. So I draw my straight line up to 2k. Then from 2k, the curve goes down up to 4, but in form of a straight line as well. So this is the function of x is equal to 4k into 1 minus x out of 4. Then this is the function of x is equal to kx. Therefore, if the question says, hence find k, now by all means you can see the mode. The mode is 2k. I mean, the mode is 2, because the highest value of f of x is 2k, which is equal to 2. Now, the other part is asking us for the value of k. The value of k, you need to get the area under the graph. So area under the graph is going to be equal to r half bh. But the total area under the graph is supposed to be equal to 1, because the total area predicts the total probability. So the total probability has to be equal to 1 as per the earlier definitions, and therefore it will give us r half times 4 times the height, which is 2k. The answer is 1. I lose the 1, the 2 by dividing. My k is finally equal to a quarter. So if k is a quarter, still when you substitute here, you will have this function becoming a half, which is the highest value. Though it is common but it's not meaning that all the time mod is a half, mod is 2. I mean, if probability of the mod is a half, and then the probability of the value of x which corresponds to that is always 2. We are just unlucky that the examples we have are predicting that. Okay, let's have one more before we can introduce something else, unless someone has a question. Actually, they can even give us the opposites, then they ask us to work backwards. I'm going to give you some of those values. Okay, let's first have this graph. No questions. Example 4. So one of the advantages of these curves, when you look at it, the highest point, the x corresponding to that is the mod. A continuous random variable y has a PDF f of y given by 0 less or equal to y. It has 0 between 0 or less or equal to 1. No, it was written in a funny way. It was not written like that. It was written like this: 0 less or equal to y less or equal to 1. Lambda y. Then from 1 less or equal to y less or equal to 3, it has lambda. Then from 3 less or equal to y less or equal to 4, it has lambda into 4 minus y. Then 0 otherwise. 1. Sketch the PDF f of y, and hence calculate lambda. Roman 2, obtain the mean. So with that regard, we have 3 regions. Because we have 3 regions, we can have here y, f of y. So if for you are cramming all the time and you say x, f of x, wrong presentation, so 0. So you have to be very careful. So it has 2 values. And the second region has 1 less than or equal to y less than or equal to 3. Then the third region has 3 less or equal to y less or equal to 4. And in this region also we have 2 values there we can use to estimate. So the first one has 0 and 1. The second one has 1 and 3. That one has 3 and 4. In the first region, when y is 0, we get 0. When y is 1, we get lambda. In the second region, do you see the second region? It is very tricky. It does not have y. It means you get that very function all the time. Even if you substitute y is 1, y is 2, y is 2.5, y is 2.9999, up to y is 3. So both of them have lambda here, lambda there. So because it is still 3, in the third case, when you put there 3, you'll get 4 minus 3, which is 1. 1 times lambda, you still get lambda. And then finally, when y is 4, you get 0. So this goes back to 0. So the coordinates will be in this region 0, 0, and 1 lambda. In this one, 1 lambda and 3 lambda. In this one, 3 lambda and 4, 0. We are ready to sketch. Since we are ready to sketch, we can sketch the graph and see how it looks like. So this is y, this is f of y. So when you look at our functions, they are all linear. The first one is a positive gradient up to when y is lambda. F of x is lambda. F of y, sorry, is lambda. So that occurs between 0 and 1. Then we have 1 and 3. Then we have 3 and what? 4. So from lambda, from 1 and lambda, between 1 and 0, the curve is a straight line. When it reaches lambda, the curve maintains lambda throughout until you reach 3. So this is lambda as the function f of y up to when you arrive at 3. Then after 3, the curve goes back to 4, 0 by following a negative gradient because y is negative in the region between 4 and 3, or 3 and 4. So for that reason, you are going to sketch a negative gradient downwards like that. And that is how our graph looks like. So, because that is our graph, it is between 0 to 4. They asked us for the mean, not so. So the mean can be estimated to be half of the graph. Where half of the graph lies, which is 0.2, is where the mean is. So our mean is 2. Then you can see that this is f of y, which is what? Lambda y. This one is lambda. This is f of y, which is actually lambda into 4 minus y. Then this one is f of y is lambda. Total area under the graph, this is the trapezium. Area is equal to r half h of a plus b, which is going to be equal to r half of h. The height is lambda. The a is 3 minus 2. 3 minus 1 is 2. Plus the longest is b, which is 4 minus 0, which is 4. The whole of this sum has to be equal to 1. Because this is 2 and 6, you'll get 3 lambda is 1. Your lambda is a third. And thus, we would have attempted the question as per what it wanted. Okay, let me show you this other technique before I can introduce. Yes, questions?
Yes, teacher.
Go ahead.
Please, I pardon on how we got this other the values of what? Of f of y here in the middle bit.
The values of
F of
y in the middle. How I got lambda to be a constant.
Yes, teacher.
Okay, do you see this part here?
So which one?
Come here to example 4. The part in the question. The question says between 1 and 3, f of y is lambda.
Yes, teacher.
You see, it has no y on it, not so? If it
Yeah.
has no y, it means it is a constant. So between 1 and 3, lambda is the only value there. Even if you put 1, even if you put 2, whatever value you substitute there, it's not changing. It remains as what? Lambda. That's why it remained lambda throughout. Okay? So that's how I got this to be lambda. Because, for example, if you have y is equal to 2, it means the line y is 2 is here. That even if you have 1, 2, 3, 4 up to infinity, all those values of x do not matter. The value of y remains the same. But if I have y is equal to 2x, then this one changes as this slope. It is not constant. Why? Because it goes on changing the values of y. So in that case, it requires you to have knowledge of coordinate geometry to confirm that actually this was not changing. Okay. Another item.
So how did you get the mean?
How did I get the mean? The mean was got by looking at the graph, and then we got the half of the region of the graph. So where is the half of this graph? According to this graph, the half is between 0 and, because the highest value is 4, 0 plus 4 divided by 2, you'll get the average, which is what? Which is 2. So that's how I got the 2, the average value. Or half of the what? The graph will give, if you know that this is the perfect half of the graph, the corresponding x values when you get the half of the graph will predict for you the mean.
Okay, so thank you.
Okay. F of x, this is by example 6. F of x is given by k1 x 1 less or equal to x less or equal to 3. K2 x 3 less x less or equal to 4. 0 elsewhere. Given that f of 3.5 is equal to 3 out of 11, find the values of K1 and K2. Where K1 and K2 are what? Are constants. So according to this, we have been given the function when f is 3.5, the probability is 3 out of 11. So that is in which region? It is between 3 and 4. So when you substitute 3.5, you'll get, for example, if you see that this is 3.5, they have given us k is 1. If it stops somewhere around here, and that's where our 3.5 is, then to reach 4, you have a balance of 0.5. So between 3 less x less 4, and also you have between 1 less x less 3. We know one thing, that the function at x is 3 in this region is the same as the function at x is 3 in this one. And if that value is p, it is supposed to be the same value here. So that means that if I substitute 3 in the first region, I'll have 3k1 is equal to p. In the second region, I'll have 3k2 is equal to p. But this is supposed to be something I'm missing out here. If the first one is 3k1, then the second one would be I go back to these curves. There's something I wanted to show you. What is it? When you look at these functions, you know when you put x is 4, you'll get 4k2. When you put x is 3, you'll get 3k2. And if I put, according to this one, they said if it's 3.5, then this 3.5 should be coming from. There's something I'm missing with this function. I want to see what the curve question was saying. Question was saying, given that 3, 5, I think it's supposed to be 3.5, which is 4. When you put f of when you put f of 2, it means you're getting the probability of 2k, which is the same as there's something I'm missing here. If these values at the boundary are the same, then we should have expected 3k1 to be equal to 3k2. But the values of k can't be the same. What do you think? Might be losing out something. Anyone make a suggestion? Yes, Chasimire.
Teacher, I was thinking that we first use the 3.5 to find the value of K2, since it is in between the range of 3 and 4. So we use that 3.5 with the K2, which will be equal to 3 out of 11 to find the value of K2. And when we have the value of K2, we use the 3 to find the 3. After getting the value using the function of f of 3, then we find the value of k1 by equating it to that function of f of 3. Shall get the answer.
If I have f of 3.5, this is the same as saying, according to what the function says, it's the same as saying K2, you get the probability from 4, 3.5. Because remember, if you to get the probability, we integrate from a given value to another one. So that means it is from 4.5 to, from 4 to 3.5. So this will give us what? This will give us K times 0.5, which is K2. But the whole of this was given as 3 out of 11. From this region now, you can get K2 is equal to 3 out of 11 times 2 out of 1. So this will give us K2 as 6 out of 11. Children, you are on and off. Your network maybe is very worse. Now, since we have got K2,
So I beg your pardon on how we get K2.
but then K2. I've considered this.
Yes, teacher.
If this is where 3.5 is, and this is where 4 is, yeah, because 4 is the last value. 4, you know, has a probability of 4 comes when you get to investigate. If you to investigate when 4 is, if you remember, if you're to look for the probability, we have been seeing that we integrate. I mean, we substitute the function f of x is equal to something, and then you get the probability. Now, when we have 3.5 as f of x, 3.5 lies between 3 and 4. If it lies between 3 and 4, it means when I get the probability between this region, it will be corresponding to this, which is 3 out of 11. So that's why I ended up saying when I subtract, because now here it will be on the x-axis, on the function, on the y-axis, because the y-axis has f of x, and if it has f of x, then at the point where you have 3 out of 11, we are trying to see that we are getting this. It lies within a given gap. It is not just at a given point. That probability lies within a given gap. Because according to what was given, they said, given 3.5 is equal to 3 out of 4. 3 out of 11, sorry. There's an explanation I'm missing here. And I don't have my text for probability with me. Let me see. It's down in the other boxes. I think I'll come back and elaborate on this function. There's something I'm missing to explain about these intervals, how they are considered when we have a given interval given as given in terms, just like the way we had magnitude. How does it come about to split it? There's an explanation I'm missing. I think I will need to have to take a look at one of my books, and I perhaps come back and take a look. But if you get the K2, then now you can easily reduce the K1. And in that case, you would see that because K1, we are substituting between 1 and 3. That's where K1 is. So if f is f of 3, f of 3 is equal to 3K1. Then f of 1 then when you come to K2, there's something which is wrong here, which I don't get very well. This is in case 1. Then in case 2, it's supposed to be, if you have K2, supposed to be 3 of K, no, it's supposed to be, for the case of 0 of 3 less or equal to x less or equal to 4. In this region, you'll see that K2 would be, there's a reason why we subtract, but I'm not getting the definition right. Let me first pause this number. I'll have to first take a keen look from one of my books. You remind me about this number 6. There's something I'm not getting. Okay, now I want to use the graphs and redesign f of x. That is how to obtain the PDF from the graphs. How to obtain the PDFs from the graphs. And example 1, a continuous random variable. Continuous random variable x has a PDF f of x as shown below. So they can sketch it in a graph. Then they ask you to work backwards. So like this.
Excuse me.
Yes, please.
Sir, I was wondering on this number 6, what if we form some kind of simultaneous equations?
That is if you substitute and then you equate to 1.
Yes, teacher. For this, then, like for the f of 3.5, we also work that out since it's equal to 3 out of 11, form some kind of simultaneous equations.
Yeah, I'll have to review that number. That's why I've said we should pause it now. I never wanted it to take all our time because my intention would be halted for finishing these graphs. I'm going to take a look at it. I'll be back with it, perhaps either within the course of the week on the group or before the next lesson. I'll have a comment on it. But we can try out all those avenues. The answers are 6 out of 11 and 2 out of 11. But the explanations were the problem, is what I wanted. The answers are 6 out of 11 and K1 is 2 out of 11, while K2 is 6 out of 11. Those are the answers. So here the question says, they have given you the graph. And this graph given to you has a 2 here, as I think this is 5. It has this as 2 lambda. Find the value of lambda. Says find the value of lambda and express f of x algebraically. Now, for the value of lambda, of course, we can use area and a graph. We know that a half BH is supposed to be equal to 1, which is a half times 5 times 2 lambda is equal to 1. I lose the 2. This will confirm lambda to be 1 out of what? 5. Now, these are all straight lines. And now we have regions that is between 0 and 2. This is f of x. This is x. So between 0 and 2, we have a line. So if we have a line, we can do this. We can estimate, we can assume. We have a point somewhere here. That point is defined by f of x. And then we have another point down here defined by x. But the gradient, which is f of x minus 0 out of x minus 2, is the same gradient when I use 2 lambda minus 0 out of 2 minus 0. That is, I'm using the reference point as the origin, and I'm getting the gradient due to this point 1, P1, and the gradient due to this point P2. The gradient is the same because it's the same straight line. Therefore, f of x, sorry, no, this is supposed to be 0 because I'm using 0, 0. So f of x is going to be equal to 2 lambda out of 2 times x. So in that region, f of x is equal to lambda x. Because lambda is a fifth, it's going to be equal to 1 out of 5 what? X. And that is the first case. For the second case, it's also a line. I can call this point P3. P3 having coordinates x, f of x. Then get the gradient of P3 is supposed to be called the gradient of P2. But now there is a point down here, which is what? Which is 5, 0. Well, there is a point up here, which is 2 lambda. So we shall expect f of x, this is between 0 less or equal to x less or equal to 5. 0 minus f of x minus 0 out of x minus 5 is going to be equal to, what if I use the other one, which is up there, it will be 2 lambda minus 0 out of 2, out of what? 2 minus 5. Then I'll have f of x is equal to 2 lambda out of negative 3 times x minus 5. When the negative goes up, you will get f of x is equal to a negative, okay, a 2 out of 3 lambda into 5 minus x. You realize that this becomes 2 out of 3 of lambda is what? 1 over 5, eh? So times 1 over 5 into 5 minus x. Finally, f of x becomes 2 out of 15 into 5 minus x. So finally, our function f of x will become, to express it algebraically, you will say the first function is 1 over 5 of x in the region between 0 less or equal to x less or equal to 2. Then the second one is 2 out of 15 of 5 minus x in the region of 2 less of x less or equal to 5. Then we have 0 otherwise. And that is how you would have expressed it algebraically. So it requires you to bring in knowledge of geometry because you are extracting work from the graph. And then you use the knowledge of gradients. It is a key for us to be in position to define that function. I've seen several hands. Can I have people's questions? I saw, is it Trevor first? Or Trevor, something? Then after Tushime. Yes, Trevor.
Okay. Teacher, why are we equating the area to 1?
Why are we equating the area to 1? Oh, it is because it is area under a graph. Because f of x is a probability, the total probability must sum up to 1. So the total area under the graph, because do you know why we say it's area under the graph? It is because this area lies within the entire y-axis. So this is the summation of f of x. It is supposed to be equal to 1 because f of x, they are functions, but these functions are probabilities. They are probabilities compressed in terms of functions. But when you sum all of them up in those regions, they must sum up to 1 because the function is generally 1 as f of x, though it is split because of the different regions. It behaves differently in different regions. But when you sum all the regions, how they behave, you must get the total probability, which is 1. Another hand? I saw another hand.
Yeah, I'm not getting how you are getting like the first gradient f of x minus 0 out of x minus 0.
Hey, okay. Look here. I'm getting the gradient at the origin, which is 0, 0, and this point P, which is x, f of x. Are we together? Now, you would have f of x minus 0 out of x minus 0. Is that better? Then this one would give you 2 lambda minus 0. 2 minus 0.
Okay.
You okay now?
Yes, sir.
Another person?
Sir, for me, I've not understood the whole number.
You've not understood the whole number. Okay. Can I do the next one so that maybe you pay more attention on the next one? Because it's still the same idea. Yeah, let me use the next one, but it's a very interesting example. The next question says, the PDF of a continuous random variable, x is represented graphically as shown. It's a very interesting graph. Agatha, you're just coming in or what? The highest value here is 6K. We have a value here of 2K. So we have the highest point occurring at 2. Okay, they are all lines. This is 0. We have here 4K. Who can predict for me the mode straight away?
Two.
Correct. So here we are. The first question is saying, obtain the mode. The mode can be obtained. And if it's obtained, we can split the regions. I mean, says obtain the value of K. I can call this triangle the upper one, region 1. I can call this one 2, the trapezium. Then I can call this rectangle 3. Then my colleague was asking earlier on, why is the area equal to 1? It is because we are summing up all the probabilities or all the f of x. So total area is supposed to be equal to area of the trapezium, which is a half h into a plus b, area of the triangle, which is a half bh, plus area of a rectangle, which is length times width. All this should sum up to 1. The trapezium has a height of 2K. This height is 2K. So it will give us a half times 2K into A is going to be 3 plus B, which is going to be, we cannot estimate B. Okay. There's another option. I cannot estimate that B because this point is not known. Let me use this other option. I'm going to use another option, which is here, which I've seen. I can call the whole of this triangle 1. I can call this trapezium 2. I can call the rectangle 3. Have you seen that? I think that is better. Now, the first triangle is a half. Its base is 2. Its height is 6K. Plus the trapezium, its height is going to be 3 minus 2. You get 1, which is a half times 1. The longest side is 4K, is 6K. Plus the shortest side is going to be 2K. Then lastly, plus a rectangle, which is going to give us 2K times 2. Why? Look here. This is 2 in between here. Then this side is 2K. This is the height of the trapezium, which is 1. Then this short side is 2K. Then this long side is 6K. This 6K serves as the same height for this right angled triangle, which has a base of 2 and then times 6K. So that's how I came about it. So this is supposed to sum up to 1. So with this, I'll get 6K plus 4K plus 4K is equal to 1. With this reason, the K is going to be equal to 1 out of 14. Now, my friend was asking about the previous number, how I got the different values. You do not understand the entire number. Now look here. First, identify the points we have. The origin has a point 0, 0. This point up here has coordinates of 2, 6K. This one has coordinates of 3 and what? And 2K. Lastly, this one has coordinates of what? 5 and 2K. Now, you assume a point anywhere. Assume here you have a point like x, f of x. Also assume somewhere here x, f of x. Also you'll assume here x, f of x. Then you get those gradients. They are supposed to be the same. So the first gradient, I can call this point P1, point P2, point P3. So between 0, less or equal to x, less or equal to 2, we shall have f of x minus 0 out of x minus 0 is equal to 6k minus 0 out of 2 minus 0. I'll have f of x is equal to 3k of x, which will give me 3 out of 14 of x. That is case 1. My friend who was asking the question previously, is this better? The lady who asked.
Yes, teacher.
Okay. Can you try to give me the gradient for the second region? Between 2 less or equal to 3 less x less or equal to 3. Give me the gradient for the second region. I want to start with f of x. I can use which point? I can use this point which is lower, this one. So f of x minus what? Lady. You know f of x corresponds to y. And the gradients are changing y over changing x. Eh? So it's f of x minus, minus.
Okay.
Very good. Then down we shall have x minus. X minus 3 is equal to the same gradient if I had used 6k minus minus what?
3K.
6K minus 2K.
Minus 2K, sorry.
Yeah. Over 2 minus 3. People avoid using the x and f of x again. Use it once. Yeah? When you use it again, you have a simultaneous equation, which will mix you very well. So on algebra, we shall attain, if you carry out the algebra, we shall attain f of x minus 2k is going to realize 4k out of -1 times x minus 3. This will give us f of x is equal to 2k minus 4k into x minus 3. This 3k and the 4k gives us a positive 12 to give me a 14k minus 4k of x. Because k is 14, 1 over 14, I'll get 14 over 14, a minus k out of 14 times x. Finally, this function will become 1 minus 4 out of 14 of x. X is negative, corresponding to a negative gradient. We're on the right track. Then the last one is the region between 3 less or equal to x less or equal to 5. Yeah. Now for this last one, it's a straight line. Yeah. But some of us may not be able to see that it's a straight line, so it's a constant. So we need to prove that it's a constant. So I'll have f of x minus 2k out of x minus 5 is equal to 2k minus 2k out of 3 minus 5. The whole of this is 0. Not so. Corresponding the x minus 5 will meet the 0. So f of x remains as 2k, which is a constant, which is 2 out of 14. And the answer is 1 out of 7. Finally, our equation of f of x will become, the first region was 3 out of 14 of x between 0 less or equal to x less or equal to 2. The second one has been 1 minus 4 out of 14 of x. That is between 2 less or equal to x less or equal to 3. The third one has been 1 out of 7. This is between 3 less or equal to x less or equal to 5. Then these ones were 4, 0 elsewhere. That is how we have gone about this function. So, having realized the function, we now know the rest of the items, we can find them. X beyond 1 and x what? This one I can just guide you. Probability of x beyond 1, given x is less than 4, you're supposed to get probability between 1 less or equal to x less or equal to 4. Okay, even if you don't put equal to, divided by probability of x is less than 4. So you integrate, get the answers, and you divide. The expectation also, we know how to do it. The mode, we have already seen it. So the basic point of today, we are to find how the curve can be sketched and how to extract information from the curve back to the equations. And I think that has been achieved, unless someone has a question. Then next time, I'll show you how we get the mode and the median. But the mode, sometimes you can get it using differentiation. So I'll show you using differentiation how we get the mode and how we get the median. Median, I require integration. So I expect you to come when you're very good at integration and differentiation. So we have around two more lessons to finish this. Any questions? I see someone in the chat. We have 7 minutes. Where does the x in the equation come from? Hey, we assume there is a point on the line, just like when you're looking for the equation of a line. Yeah? And then you say you've been given what? A point 2, 3. And they ask you to find the equation of the line which has a point 2, 3. Yeah? And perhaps another point which is 4, 1. You first get their gradient m. Then assume another point x what? xy, whereby y minus n of the points out of x for that same point must also give you the gradient. Then you cross multiply and make y the subject. It is the knowledge you are using. So that person, Agatha, that's what you're asking. Someone else had unmuted? Yes?
Excuse, teacher.
Yes, please.
If someone has used 2 less than x less than 3 instead of the less than or equal to, will that person be penalized?
No, it's okay. Where?
For the inequalities.
Yeah, for the inequality, it is okay. It is fine. Any other concern? Please finalize. Economics is on the way. 6 minutes away.
Teacher, can you please go back on the previous page?
Where? The previous one, immediate one.
Take a screenshot.
That one?
Yes, I didn't take a screenshot.
Okay, do.
Yes. Yeah. No.
Okay, if no questions, I think we can stop here.